Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns integrating y equals ax to the power n. This guide describes how to integrate functions of the form y equals ax to the power n. It introduces the power rule of integration and gives a method for checking your integration by differentiating back. This guide also discusses the special case of n equals minus 1. Introduction. Many problems in calculus involve functions of the form y equals ax to the power n, and this general function covers polynomials, reciprocal functions and roots. The study guide, Differentiating y equals ax to the power n, introduced a method to find the derivative of these functions called the power rule for differentiation. This study guide is about integrating functions of the form y equals ax to the power n and takes a similar approach by introducing the power rule for integration. However, there is a slight difference between the two approaches which you should be aware of. Importantly, the power rule for integration does not work when n equals minus 1. The reason for this and its solution is discussed in this guide. This guide only has examples of indefinite integrals, integrals without limits on the integral sign but with a plus c at the end of the answers. But the same techniques apply to definite integrals. See study guide, Definite Integrals. To help you get the most out of this guide, a thorough understanding of the laws of indices and the rules of arithmetic involving fractions is essential. See study guides, Laws of Indices, Adding and Subtracting Fractions, and Multiplying and Dividing Fractions. Also, as integration and differentiation are closely linked, you should also read the study guides, Differentiating y equals ax to the power n, Differentiating Basic Functions, and What is Integration? The power rule for integration. The power rule for the integration of a function of the form y equals ax to the n is if y equals ax to the power n, if n does not equal minus 1, then the integral of ax to the power n with respect to x equals a multiplied by x to the power n plus 1 divided by n plus 1 plus c. The power rule works when a and n are any number, positive, negative, fraction or decimal, apart from when n equals minus 1. If n equals minus 1, you will be dividing by 0 in the answer. Dividing by 0 is not allowed in mathematics. In fact, n equals minus 1 is a special case which requires its own rule and is discussed towards the end of this guide. Indefinite integration can be thought of as the inverse operation to differentiation. See study guide, What is Integration? If you integrate a function and then differentiate it, you return to the original function. Therefore, the power law for integration is the inverse of the power rule for differentiation, which says if y equals ax to the power n, then the derivative dy by dx equals a multiplied by n multiplied by x to the power n minus 1, and can be summarised as you subtract 1 from the power and multiply by the old power n. So, to integrate y equals ax to the power n, you have to do the reverse. Add 1 to the power n and divide by the new power. It is common for the process of integration and differentiation to become confused, i.e., you differentiate when you should integrate and vice versa. However, paying careful attention to the questions that you are asked should help you to choose the correct process. The following might help you remember which one to do. Differentiation decreases the power. Dy by dx equals a n x to the power n minus 1. Integration increases the power. The integral of ax to the n dx equals a x to the power n plus 1 divided by n plus 1 plus c. Using the power rule for integration. As with the power rule for differentiation, to use the power rule for integration successfully, you will need to become comfortable with how the two parts of the power rule interact. To begin with, you must be able to identify those functions which can be, and just as importantly those which cannot be, integrated using the power rule. It may be necessary to manipulate a function in some way to see that it fits the pattern y equals ax to the power n. When this is done, you need to be able to identify the values of a and n, substitute them into the second part of the rule, and then simplify if necessary to give the answer. In the following examples, you will see a variety of functions which can be integrated using the power rule. The examples will cover a variety of different cases for a and n. All the examples will be indefinite integrals, so you will see a constant c added to the answer. Example: integrate y equals 4x squared with respect to x. When using the power rule for integration, you must first ensure that the function you are integrating fits the pattern of the rule. In other words, can you correctly identify a and n? It may help to write the first part of the power rule for integration underneath the function you are integrating to help you see the pattern. Here, y equals 4x squared potentially fits the pattern y equals ax to the power n. You can see this fits the power rule for integration with a equals 4 and n equals 2. So, inserting the values of a and n into the power rule gives the integral of a x to the n dx equals a multiplied by x to the n plus 1 divided by n plus 1 plus c becomes the integral of 4x squared dx equals 4, which is a, multiplied by x to the power 2 plus 1 divided by 2 plus 1 using n equals 2 plus c. As 2 plus 1 equals 3, the answer is 4x cubed divided by 3 plus c. Notice that the question, integrate y equals 4x squared with respect to x, is written symbolically as this, and the answer does not contain either an integral sign or dx. This is because the integral has been performed to give a function, and they are no longer necessary. It is a common mistake for symbols to be either missing or added unnecessarily to questions involving integration. So remember, integrals themselves have integration signs and a dx at the end, but the results of integration, the answers, do not. Example with a hidden coefficient. Integrate y equals x to the power 4 with respect to x. By writing the first part of the rule underneath the question, can you see that n equals 4? However, the value of a is not obvious, as there seems to be no number in front of the x. It is a common mistake to assume that a is 0, as it is absent, but this is not the case. If a was 0, then the whole function would be 0, as anything multiplied by 0 is 0. In fact, the function can be rewritten as y equals 1 multiplied by x to the power 4, and so a equals 1. Using these values for a and n in the power rule for integration gives the integral of ax to the n dx equals a multiplied by x to the power n plus 1 divided by n plus 1 plus c. So, the integral of 1 multiplied by x to the 4 dx equals 1 multiplied by x to the power 4 plus 1 divided by 4 plus 1 plus c, which equals x to the 5 divided by 5 plus c, as 4 plus 1 equals 5. These next two examples highlight the common functions y equals a multiplied by x and y equals a, both of which illustrate cases of y equals a x to the power n with n hidden. Example: integrate y equals 5x with respect to x. Using the law of indices, x equals x to the power 1, the function y equals 5x can be rewritten as y equals 5x to the power 1. This fits the power rule with a equals 5 and n equals 1. Using these values for a and n in the power rule gives the integral of 5x dx equals the integral of 5x to the power 1 dx, which equals 5 multiplied by x to the power 1 plus 1, all divided by 1 plus 1, plus c, which equals 5x squared divided by 2, plus c. Example: integrate the constant y equals 3 with respect to x. Using the law of indices, x to the power 0 equals 1, you can rewrite the function y equals 3 as y equals 3 multiplied by x to the power 0. So here you use a equals 3 and n equals 0 in the power rule for integration. The integral of 3 dx equals the integral of 3 multiplied by x to the power 0 dx, which equals 3 multiplied by x to the power 0 plus 1 divided by 0 plus 1 plus c, which equals 3x to the power 1 divided by 1 plus c, which equals 3x plus c. In all of the examples above, identifying a and n, and hence using the power rule to integrate the function, is relatively straightforward. The following example is a little more difficult and relies on both a good knowledge of the laws of indices and fractions to identify a and n. Example: integrate y equals the square root of x divided by 7 with respect to x. Upon first inspection, this function does not look like the pattern y equals ax to the power n. However, when you interpret the divide by 7 as a multiply by 1/7 and use the laws of indices to see that the square root of x equals x to the power half, the function becomes y equals 1/7 multiplied by x to the power half, which can be integrated using the power rule for integration, with a equals 1/7 and n equal to 1/2. So, the integral of the square root of x divided by 7 dx equals the integral of 1/7 multiplied by x to the power 1/2 dx, which equals 1/7 multiplied by x to the power 1/2 plus 1, all divided by 1/2 plus 1, plus c, which equals 1/7 multiplied by x to the power 3 over 2, divided by 3 over 2, plus c, which equals 2x to the power 3 over 2, divided by 21, plus c. Integrating negative powers of x, other than n equals -1. As mentioned in the introduction, the power rule for integration works for all negative powers except n equals -1. For this section, it is useful to recall the laws of indices. X to the minus n equals 1 divided by x to the power n, which allows you to replace positive powers of x below a dividing line with a negative power of x. Example: integrate the function y equals 6 divided by x cubed with respect to x. Using the law of indices above, you can rewrite the function in question as y equals 6 multiplied by x to the minus 3, and so you can use the power law for integration with a equals 6 and n equals -3 to integrate the function. The integral of 6 divided by x cubed dx equals the integral of 6 multiplied by x to the -3 dx, which equals 6 multiplied by x to the power -3 plus 1 divided by -3 plus 1 plus c. This equals 6 multiplied by x to the power -2 divided by -2 plus c, which equals -3 multiplied by x to the -2 plus c. Integrating the special case of n equals minus 1. When n equals minus 1, the power law for integration would mean adding 1 to minus 1 to give 0, and then dividing the answer by it. But in mathematics, dividing by 0 is an undefined operation, and always means something is wrong. The solution to this problem lies in differentiation. Remember that, in the study guide, Differentiating Basic Functions, the rule that if y equals a multiplied by the natural logarithm of x, then dy by dx equals a multiplied by x to the power minus 1, which equals a divided by x. So, because integration is the reverse of differentiation, you can see that if y equals a multiplied by x to the power minus 1, which equals a divided by x, then the integral of a divided by x dx equals the integral of a multiplied by x to the power minus 1 dx, which equals a multiplied by the logarithm of x plus c, which is the rule to integrate functions when n equals minus 1. Example: integrate the function y equals 6 divided by x with respect to x. As the function can be written y equals 6 multiplied by x to the minus 1, you can see here that a equals 6 and n equals minus 1, and you cannot use the power rule for integration. Instead, use the above rule for when n equals minus 1 to give the integral of 6 divided by x dx equals the integral of 6 multiplied by x to the minus 1 dx, which equals 6 multiplied by the natural logarithm of x plus c. Checking your integration. In general, integrating is harder than differentiating, but if you have a good understanding of differentiation, you can check to see if you have integrated correctly by differentiating back. Remember, differentiating is the inverse of integrating, and so when you differentiate your answer, you should get the original function that you integrated. Example: confirm that the integral of 3 over 4x squared dx equals minus 3 over 4x plus c. You can confirm that the integral is correct by using the power rule of differentiation to see if the derivative of minus 3 over 4x plus c with respect to x is indeed 3 over 4x squared. Differentiating when y equals minus 3 over 4x plus c, which equals minus 3 over 4 multiplied by x to the minus 1 plus c, then dy by dx equals minus 3 over 4 multiplied by minus 1 multiplied by x to the power minus 1 using the power rule for differentiation, plus 0, which is the derivative of the constant c, equals 3 over 4 multiplied by x to the minus 2, which equals 3 over 4x squared, which is the function you integrated to begin with, and so the statement is correct. You can look back at the examples in this sheet and check them by differentiating back. You should differentiate back each time you perform an integral until you are confident with the technique. Further guidance and information. If you have any further questions about calculus or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students' office and on its website. These include questions to practice, model solutions, and webcasts illustrating essential skills.